So this is the Kaplan-Meier estimate, which allows us to get a survival function that we estimate from a population. And so what we did was we're able to represent the population using survival data from which we built the Kaplan-Meier survival model. The key thing about this model is that the survival function that we estimate is applied to all the patients in the population. It isn't specific to a particular patient. We can compute the Kaplan-Meier curves or the survival curves for two different populations and compare them against each other. So for example, let's say we wanted to know the prognosis for patients with stage 3 cancer and with stage 4 cancer. We can build two separate survival functions using the Kaplan-Meier estimate, and we can graph the Kaplan-Meier estimates for the survival on the same plot. So here in orange, we have the plot for the Kaplan-Meier estimate of the survival for stage 4, and in blue for stage 3. So if we wanted to tell the prognosis or the survival probability for any patient in the population, we would simply look up, given a time, let's say 50, what the survival probability or the Y value was at that point to tell the difference in the survival probabilities for patients between the two populations. And so we've seen how we can use the Kaplan-Meier estimate to be able to get these survival curves.
This week, we discussed the problem of survival analysis. Using survival modeling, we saw how we could now model survival up to any time t. We looked at one of the key features of data in survival analysis, right censoring. Right censoring, as we saw, is a form of missing data problem in which time to the event is not observed because the study was terminated or because the patient left the study prior to experiencing an event. We finally looked at the Kaplan-Meier estimator, which takes censored observations into account to estimate a survival function for the whole population. What we haven't looked at yet is how we can make individualized estimate of survival for patients by taking into account their particular profile. Next week, we'll look at strategies to build and evaluate such individualized survival prediction models. Until then.